Okay, we are doing the Intext problems because I stopped doing that in between and I completed a bunch of topics and I wanted to finish that too. So question number 2.8, it's in, I don't know which page number, it's right after, okay, yeah, it's on page number 49 of your textbooks. This particular question is or deals with Raoult's law. Okay, so we've been given the vapor pressure of pure liquids A and B are 450 and 700 mmHg respectively at 350 Kelvin. Find out the composition of the liquid mixture if the total vapor pressure is 600 mmHg. And we also need to find the composition of the vapor phase. So this is completely, totally, absolutely related to Raoult's law. So we have two liquids, A and B. Now, we've been given the vapor pressure of the pure components. So let's write down what's given to us. P naught A equals to 450 mmHg. P naught B equals to 700 mmHg. Now we need to find the composition and we've been given the value of P total. P total equals to 600 mm of G. Okay, so first of all, let's write the equation of Raoult's law, right? So P total will be equal to P naught A plus P naught B minus P naught A into XB. Okay, so essentially we can find out the mole fraction of one of the components, and then from there we can easily calculate the mole fraction of the other component. So, and then we can also, so that would be the composition, essentially the mole fractions of both A and B. And then we need to find the composition in vapor phase, and we can use the equation related to the mole fraction in vapor phase. Okay, so these are the formulae we're going to be using for this question. So 600 mm Hg is equal to 450 mmHg plus 700 minus 450 mm. I think one of my teachers taught me that I always need to write units, and ever since they taught me this, I have never been not able to write, the units. So 600 mm minus 400, oh sorry, 450, right? So 450 will be equal to, basically I'm just going to be subtracting both those values. That gives us 250. Actually, that 5 is not clear. Let me just rewrite it, just in case. So 250 mmHg into XB. So this gives us 150 divided by 250. My favorite part, we get to cancel these units, and we should not have units. If you do, that's concerning. So that's gives us the mole fraction, because the mole fraction does not have units, right? So XB equals to 0.6. So this on simplification gives us XB, that is 0.6. Now XA plus XB equals to 1. XA equals to 1 minus XB. So that will be equal to 1 minus 0.6, that is 0.4. So the composition of the liquid mixture is going to be xb, that is the mole fraction of b, is 0.6 and the mole fraction of a is 0.4. And you could obviously do it the other way around, where you calculate the value of xa, and then you will reach the same conclusion in the end. So you can do it either way. Okay. Basically, in that case, you would have PB naught plus PA naught minus PB naught into XA. So that's how you would calculate the value of XA directly from P total. But and then you would then calculate the value of XB. I would definitely recommend not doing this whole process for both XA and XB, because one XA plus XB equals to 1. All right. Now, in your textbooks, the last part was given where you have the mole fraction. Actually, let me scroll down. I'm going to scroll down a bit. All right. Now, we have the mole fraction in vapor phase would be given as y, a or b. Okay, so y, let's take a. Ya would be equal to pa divided by p total. That's because the equation given to you in your textbook is that pa equals to ya into P total. So we're just rearranging this equation for us to get the value of Ya, which is the mole fraction in the vapor phase. So for this, we obviously need to calculate the value of Pa. So Pa is going to be equal to Pa naught into Xa. Right. So Pa naught into Xa equals to Pa. That's the basis of Raoult's law. So this is equal to 450 mm Hg into 0.4. That is equal to 180. And then Pb equals to Pb naught into Xb. So for this is what, 700. So 700 mm Hg into 0.6. So this, on simplification, gives us the value of Pb, which is equal to 420 mm Hg. So you can do it either way. Obviously, the mole fraction of the vapor phase can also be totaled as Ya plus Yb equals to 1, right? Um, I could have done that way as well. Oh well. Since we are going this way, might as well finish it. So Ya will be equal to Pa, which is 450 mm Hg div oh sorry. It's not 450, it's 180 mm Hg divided by P total, which is 600 mm. Now the units are obviously going to get cancelled, and then this, on simplification, is going to give us a value of 0.3. Similarly, Yb will be equal to, again, don't have to do this, 420 mm Hg divided by 600 mm Hg. This, again, the units are going to get cancelled, and that's going to give us 0.7. Now, if you just didn't do this, that's perfectly fine. You can just take the value of Ya, because Ya plus Yb equals to 1. So Yb will be equal to 1 minus Ya. That is equal to 1 minus 0.3, that is 0.7. So actually, when I was solving this for my notes, I did solve it all the way using this, but you can do it this way as well, and that's perfectly fine. Um, so basically, what we are doing is we're calculating the value of the mole fraction using this equation. We've been given the value of P total, PA naught, and PB naught. Using these three values, you can calculate the mole fraction of B. And then we use the XA plus XB equals to 1, and then we're able to calculate the value of XA. So this is the composition of the liquid in liquid mixture, whereas the mole fraction in the vapor phase is given as Ya equals to Pa by P total, because we know that Pa equals to Ya into P total, where Ya is the mole fraction of the vapor phase for that component. So we can calculate the value of Ya. First we calculated the value of Pa. Essentially we're using each and every equation given to you under the concept of Raoult's law. And we calculated the composition or the mole fraction of A and B in both the liquid and the vapor phases. With that, we're done with this video. In the next video, we'll be solving question 2.9. And I think that line is super straight.